So today we are talking about sequences. A sequence is essentially when you have numbers in a line and you want to figure out some sort of connection between them, right? So if I'm talking about the numbers right here on the first example, 5, 9, 13, and 17, these are my terms. So A sub 1 is how I would read that. And this is essentially your first term. So my first term is 5. And then I want to figure out if there's some sort of connection happening from 5 to 9, right? And if that connection is happening over and over and over again. So if I'm thinking about it, if I'm going from 5 to 9 to 13 to 14, I can kind of see that this is adding by 4 each time. So this is an arithmetic sequence. We've got two types, arithmetic and geometric. So an arithmetic sequences is when you're adding or subtracting each time by the same thing. In this case, from term 1 to term 2, I'm adding 4, so that is called the common difference. So I've got a common difference of 4. It's also signaled by the letter D. So D is equal to 4 right here. And I can see that the next term is found by adding in that difference. So if I want to figure out what A5 is, I would still do the same thing. I would take that number and add 4, so I can know that A5 should be 21. So that's my arithmetic sequence when I'm adding or subtracting to get to the next number. Now Desmos can do something really cool for you with this. On Desmos, if we think about it, if we build a table, I'm going to build it with my terms. So the first term was 5, second term was 9, third term was 13, and the fourth is 17. On Desmos, I have what's called regressions, right, on the calculators. Regressions calculate a good line for these numbers. And because I'm adding each time, because this is arithmetic, I want to use my linear regression. Because you see how that has that plus b part of it, kind of where it adds something at the end? That's essentially how your arithmetic functions work. So I'm going to be using this one, x1 plus b. Okay, so I want to do that because there's something really cool that Desmos can do with sequences. It can calculate what the next term is going to be. So here I'm adding in my numbers that I just found. Let me see, split this. Okay. So I'm going to add in my numbers 1, 5, 2, 9, 3, 13, and 4, 17. And then I'm going to do my linear regression. Y1 squiggly, and x1 plus b. So now I've got all those dots connected by a line. And here's how I can figure out my next term, or any term that I want, on Desmos. So if I want to double check that this is correct, that A5 is equal to 21, I'm going to put x equals 5 into Desmos. X equals 5. Oops. X equals 5. And now I can see that if I check this and I zoom out a little bit and I see where these lines cross, yes, when we have the fifth term, A5, that should be 21. So that is really cool for Desmos to do. It can kind of shortcut our way into sequences. Now, very similar to that, geometric is when you either multiply or divide to get to the next number. So right here, I've got the numbers 5, 15, 45, and 135. So if I think about it for a second, for me to get to 15, yes, I can add 10. But if I add 10 again, that's not going to get me 45. What I could do here is multiply times 3. And if I multiply 15 times 3, that's what's going to get me 45. And that keeps working over and over again. So this time, instead of having a common difference, I have a common ratio, which is the letter R. And that's how much I multiply to get to the next number. So right here, I would say R is equal to 3 because I'm multiplying by 3 each time. So the next term is always found by multiplying the previous term by the common ratio. Okay, Now, if I think about ratios and multipliers, I should be thinking about exponential regression because we've learned recently that exponential regressions, you've got your initial number, and then this b is a multiplier. So that's why I want to think about exponential regression here. So I'm going to build my table so Desmos can help me figure out. We left off at A4. I want to know what A5 is. What's the next term? So I'm going to build my table. 1, 5, 2, 15, 3, 45, and 4, 135. And this time, because this is multiplying, it's growing really, really rapidly, I'm not going to use y squiggly mx1 plus b. I'm going to use y1 squiggly ab to the power of x1. So here's how I remember the exponential as well. If I go on Desmos, right here, first I'm going to type in my numbers real quick. And I would just do this by erasing the table. That way I don't have to put x1 and y1 back in there, because sometimes you have to do that. So I would just put my numbers back in, 3, 5, and 4, 135. Okay, so here's my numbers. Now, here's how I remember y1 squiggly ab to the power of x1. You see this ab button right here? That's what gives me my exponents. So that's what I'm writing. ab power of x1. Click on log mode. Okay, so here's my line. And now if I want to do the exact same thing, where I look for the fifth term, that means A5, I can do this on Desmos by putting x equals 5 and checking where that crosses my line. So because exponential functions grow really rapidly, you might have to zoom out quite a bit, and I would keep on tapping on that green line, because eventually you're going to get a gray dot like this, and that's where they're crossing. So this lets me know my fifth term should be 405. And I can do that by double checking this number. If I multiply that times 3, so we said that was the multiplier. Yep, 405. So that's how I can use Desmos to help me out with the next term or whatever term I want. And we're going to repeat that on a couple of examples here. So example 1, I've got to determine if this is arithmetic or geometric, right? We talked about it. Arithmetic means you're moving by adding or subtracting. Geometric means you're moving by multiplying or dividing. So for me to move from 2 to 4, I could add 2, but if I add 2 again, that doesn't work. That doesn't get me 8. So another way I could go from 2 to 4, I could multiply times 2. And if I multiply 4 times 2, yes, that's going to get me 8. And it keeps working here. It gets me 16. So I know this is geometric, which means I'm going to use exponential regression. And that's my exponential regression right there. y1 squiggly ab to the power of x1. And now I want the next 3 terms. So I left off at A4, so that means I want A5, A6, and A7. So I gotta find where x is equal to 5, x is equal to 6, and where x is equal to 7. But I'm gonna do this one at a time, just so it doesn't get crazy on my screen with a bunch of lines. And my table should look like this. 1, 2, second term is 4, the third term is 8, the last term is 16. Okay, I'm going to go to my Desmos and I'm going to put those numbers in. And we said this is exponential, so I'm just going to leave that there. So my first one was 2, 4, 8, 16. So if I want a 5, next one, I'm just going to check right there, and I'm going to zoom into it a little bit more. And it's crossing at 32. So that lets me know the next one should be 32. And then A6, it's going to be 64. and A7 going to be 128. So it is jumping up quite a bit. Sometimes you might have to zoom out, but keep on clicking on that just so you can see where it's crossing. So those are my next three terms. Now it's not always going to be this regression, right? So if I look at example 2, from 7 to 1, and then from 1 to -5, I'd have to do something like -6. -6, yes, 1 minus 6 is -5, and then -5 minus 6, yes, that's -11. So in this case, it's arithmetic, which means I have to use y1 squiggly mx1 plus b. Slightly different. So my table, same thing. I'm going to draw it real quick. 1, 7, 2, 1, 3, -5, and 4, -11. So I'm going to do all those numbers on there. 7, 2, 1, 3, -5, and 4, -11. And we said we want linear regression this time, mx1 plus b. That plus, just like arithmetic, where you add stuff in, or subtracted. Okay? And now, if I want to check for the 8th term, A8, I would do x equals 8 and check where that is true. So let's see, x equals 8. Yes, I have this gray dot right there, but that's just where it's crossing the x line. I want to check where it crosses my blue line, this one. So -35. So that lets me know if I keep on doing -6, -6, -6, the 8th term should be -35. Okay, so then you've got these two problems that you can do on your own and bring them back to me for free 100 once you finish the whole paper. You got number 3, figure out is it arithmetic or geometric? What's the regression? What's the 5th term? Same thing right here on number 4. Okay. Now, if I'm given the terms instead, and I want to write a function for them or an equation for them, just like if they give me a line and I want to figure out what equation made that line, I'm going to consider a couple things. First of all, there's two things that are never going to change with your sequences when you write them down, generally right now. So this is going to stay the same. And this n minus 1 right here, that's going to stay the same. Kind of like when we had y equals your mx plus b, the numbers that we changed was the m and the b, but we left the y and the x there. So a1, that's my first term, where x is equal to 1. And then that difference is how much are you adding in or how much are you subtracting. And that, if you want a trick to find it, it should be your m. When you think about y1 squiggly mx1 plus b, that's going to be the same thing as m. On geometric sequences, so if you're multiplying instead, this still stays the same. And this exponent, don't write this nice and big like this one. This one's going to be an exponent. This is also going to stay the same. So if I'm looking at example 1, given A4 equals 224, and then A5 equals 112, and A6 equals 56, write the equation for the nth term and the sequence an. So that just means write the general equation. Okay, so I've got to figure out, is this A or G? Well, if I'm going from 224 to 112, and then 112 to 56, or kind of if I'm going backwards, if I'm going from 56 to 112 and 112 to 224, I should be able to figure out that this is really being divided by 2 each time. And another way that you can say being divided by 2, if we think about what does it mean if you have one part out of 2, it's essentially saying multiplied by a half, right? So I can say it either way. Okay, so A or G, this is geometric because it's being divided by 2 or multiplied by a half. So I want to use this format right here, the geometric format. So I know I'm going to have AN equals, then I need something for R, or what is it first? I need something for A1, not R. And it's going to be times R. And then I'm going to have the exponent of n minus 1. So that still stays the same. So what is the first term? Because I need to know A1. I don't have the first term here. Usually it starts with A1, but this time it didn't. So I need to build out my table. 4, 224, 5, 112, and 6, 56. So I'm going to build that out. And because I know this is geometric, I want to be using y1 squiggly, ab to the power of x1. Geometric, if you're multiplying, dividing, you need to be using this one. So I'm going to type that in decimals so I can help you figure out what the first term is. Let me put this on the right screen. Hopefully this shows up. You know what? I'm just going to make it big for now. Okay. So I've got 4, 224, 5, 112, and 6, 56. Geometric, y1 squiggly, ab power of x1. And we said we wanted the first term, so that's x at 1, x equals 1. Geometric, grows or decreases really rapidly. If I want the first term on this one, I'm going to have to zoom out quite a bit, but there it is. So 1792. So we found x equals 1, gave us 1792. And now my ratio. Ratio is how much is it multiplying each time, right? And we said, yes, this is dividing by 2, but if I look at my b in decimals, so I can find that looking right here, it says b equals 0.5. So that's what I said before. Really, you're multiplying this. If it's decreasing, it's going to be less than 1 when we think about multiplier. So it's being multiplied by 1/2. So here, I want to go ahead and put 1/2, multiply times a half. And then we've got the same thing, the exponent of n minus 1. So there's one way I could write it. I could also write it this way. 1792. In parentheses, your multiplier. And then n minus 1. So that's another way you might see it without the dot. Okay. If I want to do that, but with a arithmetic sequence, I'm going to look at this one right now. So here, from 4 to 12, I could add 8. And from 8 to 20, yes, I add 8 and it still works. So this is arithmetic. What is the 10th term? We can find that out in just a little bit. But first I want to focus on my sequence, writing down my sequence. So my sequence, AN, I'm just following that format, equals A1, so I need to know A1. And I need the difference here, plus the difference. Now, this could be minus the difference. It just depends on, is it increasing or decreasing right here? Since I'm going up by 8, yeah, it's going to be plus your difference. And then I've got n minus 1. This time I wrote it nice and big into the side. On here, I wrote it as an exponent. So do notice that yours should be an exponent. Okay. So now my first term, I don't actually have to do x equals 1 for that because it's right here. So That's just a 4. And my difference, I mean, I kind of figured it out already. I said I'm adding 4, or I'm adding 8 each time. So that's one way I could know. Another way is if I make my table 1, 4, 2, 12, 3, 20. And because this is arithmetic, I want to do y1 squiggly mx1 plus b. If I look at my m, my slope, that's also going to tell me what the difference is. So that should match on decimals. Let me see. I've got 1, what was it, 4, 2, 12, and 3, 20. And I want to go back to mx1 plus b. Since this is arithmetic, it's adding. Zoom back in. Arithmetic doesn't grow as fast. That's another way you can tell. Arithmetic does not grow as fast. Okay, so I've got 1, 4, and yes, we knew the first term was that. Now my m right here, it says it's 8. And we figured out that yes, I'm adding 8 each time. So if I want to trick on how to know it, how to double check it, it should match your slope. So plus 8, that was positive 8, and minus 1. So my sequence should look like an equals 4 plus 8 and minus 1. So now you've got these two examples to look at. Number 3, number 4. So you can go ahead and do those. Now, this is just random. What's the 8th term? You can ignore that for now, because you're really going to need to find the first term, right? That's what really goes into that box each time. A1, A1. Okay, so we've got those two problems. Number 3, number 4. The very last concept that we touch on is what happens if you have a recursively defined sequence. So they kind of give you the equation for it, and you have to figure out what the next term is. On arithmetic, this is essentially like your y equals. That just tells you the sequence is this. This an minus 1 is the previous term. So if I'm looking for the second term, I've got to be using the first one plus the difference. So this is the really, really big important part that you want to pay attention to, because this tells you how much are you adding or subtracting. So if I look at a sub n is equal to an minus 1 plus 3, where the first term, a1, is equal to negative 3, and n is a whole number greater than 1, so that's always true in algebra 1. What are the first 4 terms in the sequence? So I know the first one gave it to me. a1 is equal to negative 3. For me to find the second one, I want to consider this. So this just told me an, and I can see that right here, an, equals the previous term, plus 3. So this is what's different, right? Instead of having plus d, I have plus 3. So that tells me that if I want to move on to the next number, I have to add 3. So that would give me a2 is equal to negative 3 plus 3. That's 0. We'll check it on decimals. And then I'm going to move on to the next one by adding plus 3. So I want a3 equals 0 plus 3, 3. And then the last one, first 4, a4 equals 3 plus 3. That's equal to 6. So that's my first 4 terms. If I take a look at geometric, very similar as well. An, which is kind of like your y equals, your sequence is this. Here's your sequence. Your sequence is equal to the ratio. This is a really important part. Ratio times the previous term. It's still the same thing. The previous term. Okay? So my ratio is letting me know how much are you multiplying. How much you multiply. So if I'm looking at the sequence generated by this formula right here, I can see that this is still the same as this. This is still the same as this. The only thing that really changed is it's telling me that this is multiplying that previous term by 5. Multiplying by 5 this time. So if I start off with A1 equals 8, to get the next number, I'm going to multiply times 5. So 8 times 5 is A2 equals 40. And then to get A3, I'm going to do 40 times 5 equals 200. And then 200 times 5 will give me A4. So 1,000. So I can get my next 4 terms, my first 4 terms, using the geometric sequence. So you've got this example right here. You've got your starting number, and then how is it changing? Tells you right here. Same thing right here. Your starting number, and this tells you what are you multiplying to get to the next number. Okay? So you've got those examples to finish up on your own. The very last piece I do want to touch on right here is that on your independent practice, so I look at Google Classroom on decimals there, the independent practice has this problem right here in slide 3 and 4. On slide 3, this is like when it gives you the equation and you have to find A1, A2, A6. And a really easy way that I can do this on decimals is by putting in that AN using your y equals, kind of like f of x. F of x is the same thing as y. Let me go ahead and open up Classroom. Okay. So instead of putting AN in decimals, I would just use y. So y equals, and then the 7's still the same. And then in decimals, we don't usually put n or other letters. We like to exchange that with an x. So there's my line. So for A1, I'm not putting A1, I'm putting x equals 1, and I'm seeing where that crosses, right? So that's how I would do that one. And very similar in number 2, equation 2, it has that AN. I don't want AN, I want y equals, because that's how decimals works. And then 156, parentheses 1 over 2. Close that up. And then I've got that exponent of n minus 1, but same thing, I don't want to use n minus 1. I want to use x minus 1. So that gives me that curve. And to find A1, A2, A3, I just have to put x equals 1 and check where that's crossing. It's at that gray dot. That's how you start that one off. Any other questions?